Astronomers have just discovered a galaxy so distant, so impossibly ancient, it shouldn't exist. It's tiny, brilliant, and chemically advanced, just 300 million years after the Big Bang. And yet, it's real. Some now believe this changes everything, even the possibility that our universe exists inside a black hole. If that sounds insane, keep watching. Let's rewind, not to the beginning of time, but to 2022. That's when the James Webb Space Telescope, JWST, opened its golden eyes for the first time. Orbiting nearly 1.5 million kilometers from Earth at the second Lagrange point, this marvel of engineering wasn't just an upgrade. It was a time machine. Unlike Hubble, which observes mostly invisible and ultraviolet light, JWST was designed to see in the infrared, the exact kind of light that's been stretched across billions of years of cosmic expansion. That means it can detect the faintest, most ancient light in the universe, light emitted by the very first stars and the very first galaxies. Until then, Hubble had given us wonders. It discovered galaxies like GN-Z11, over 13.4 billion light-years away, an astonishing achievement. But even with all its power, Hubble had limits. It couldn't see deep enough, far enough, or early enough. JWST changed that. With a 6.5-meter gold-coated mirror, more than double the size of Hubble's, with a sunshield the size of a tennis court, JWST began peering into cosmic history with unprecedented clarity. And what it found was something that shouldn't be possible. A galaxy so old, so bright, and so chemically rich, it's forcing scientists to rethink the entire story of how the universe began. The galaxy is called MOM Z14, and it's about to challenge everything we thought we knew about the early universe. Not long after the James Webb Space Telescope opened its golden mirrors to the universe, it sent back something that stunned the astronomical community. At first, it looked like nothing more than a faint reddish blotch, almost invisible, in a small region of the sky, part of an early deep field survey. But when scientists analyzed the light coming from it, they realized they were looking at something extraordinary. A galaxy, but not just any galaxy. This one had existed only 320 million years after the Big Bang. To put that in perspective, if the universe were a human life of 100 years, this galaxy appeared when the universe was just a toddler, barely 2 years old. It was named JADES GS Z13-0, and at the time of discovery, it held the title of the most distant, oldest galaxy ever observed, over 13.6 billion light-years away. But how do we know that? The answer lies in something called Redshift, one of the key tools cosmologists use to measure time and distance in the universe. When a galaxy is moving away from us due to the expansion of space, the light it emits is stretched, just like the pitch of a siren lowers as it drives away. This stretching shifts the light toward the red end of the spectrum. The higher the red shift, the older and more distant the object. JADES GS Z13-0 had a redshift of Z equals 13.2, which means its light took over 13.6 billion years to reach us, a silent traveler from the earliest era of galaxy formation. But here's where it gets even more surprising. According to standard cosmological models, galaxies shouldn't even be able to form that quickly. The early universe was a chaotic soup of hot plasma, radiation, and barely cooled hydrogen. Matter hadn't yet settled. Gravity was only beginning to pull particles together. The first stars, the so-called population 3 stars, were just being born. And yet, JADES was already a functioning galaxy. It had structure, it had light, and most shocking of all, it was actively forming stars. Not one or two, but likely hundreds of thousands, possibly even millions, across its compact structure. And this wasn't just theoretical. Using JWST's near-infrared camera, NIR-CAM, and near-infrared spectrograph, NIR-SPEC, astronomers were able to break down the light signature and confirm the redshift through spectroscopic analysis, making this the first spectroscopically confirmed galaxy at such an extreme distance. This wasn't an error. It wasn't a glitch. This was real. And yet it defied everything we thought we knew. If galaxies were already forming this early and forming rapidly, then something was deeply wrong with our assumptions about the early universe. Was the cosmic timeline flawed? Were stars forming earlier, faster, and more efficiently than we predicted? Or were these galaxies the exceptions, strange outliers born from unknown cosmic conditions? One thing was clear: Jade's GS-Z13-0 wasn't a fluke, because just weeks later, an even older, even stranger galaxy would be uncovered. A galaxy that would break all the rules and raise even bigger questions. Just when astronomers were still absorbing the implication of Jade's GS-Z13-0, the James Webb Space Telescope pushed the limits even further. Another galaxy emerged, fainter, smaller, but even more ancient. Its name, MOM Z14. Its redshift, 14.44, placing it just 280 million years after the Big Bang. That makes it the most distant galaxy ever confirmed, a record that, for now, still holds. But distance alone isn't what makes MOM Z14 so intriguing. It's what it looks like. This galaxy is only about 500 light-years wide, a speck compared to our Milky Way's 100,000 light-year span. And yet, it's blazing with newborn stars. Based on its luminosity, MOM Z14 appears to be undergoing a rapid starburst phase, forming stars at a rate scientists didn't expect to see in such a young, small system. But perhaps most shocking of all is what's missing. There's no detectable supermassive black hole at its center. That's highly unusual. In nearly every modern galaxy with intense star formation, we've found a supermassive black hole, objects that help shape galaxies, regulate star birth, and drive their evolution. MOM Z14 defies that pattern. And there's more. When astronomers examined its spectral data, they found the galaxy was unusually rich in nitrogen, a heavier element that only forms after multiple generations of stars have lived and died. But how can that be, if this galaxy formed so soon after the Big Bang? The presence of nitrogen implies that star formation didn't just begin earlier than we thought, it began aggressively, and perhaps in ways we still don't understand. MOM Z14 isn't just an ancient galaxy. It's a cosmic contradiction, a compact, hyperactive system that may hold the key to rethinking how galaxies truly began. MOM Z14 was already puzzling. A tiny, blindingly bright galaxy just 280 million years after the Big Bang. But then came something even more astonishing. When scientists pointed the near-infrared spectrograph, NIR-SPEC, on JWST directly at it, they didn't just study the light. They broke it apart into its spectral signature. And in that light, they found a chemical fingerprint that doesn't belong in a galaxy this young. It was rich in nitrogen. Not trace amounts, not a whisper, but levels of nitrogen that should not exist so early in cosmic history. Here's why that matters. Nitrogen, like carbon, oxygen, and iron, is a heavy element. It's created inside stars during nuclear fusion. And when those stars die in supernova explosions or gentle winds, they spread their elements into space. That material then helps form the next generation of stars. It's a cosmic cycle: star birth, star death, chemical enrichment. But that cycle takes time. Generations of stars, hundreds of millions, sometimes billions of years. Mom Z14 had only existed for a few 100 million years at most, and yet it already showed signs of multiple star generations having lived and died. This changes everything, because it tells us the first stars may have formed faster, burned hotter, and ended sooner than our models predict. And not only that, they may have done so in incredibly dense environments where material was recycled almost immediately into new stars. It's a cosmic pressure cooker, a stellar nursery evolving at breakneck speed. In fact, the nitrogen levels in Mom Z14 closely resemble what we see in ancient star clusters orbiting our own Milky Way, like globular clusters, which are among the oldest structures in our galaxy. Could it be that Mom Z14 is an ancestor of those clusters? Or at least part of the same rapid ancient process? If so, then the early universe wasn't just forming stars. It was building complexity, faster and earlier than we ever imagined. Which leaves us with a chilling realization. The Big Bang might not have been followed by a dark, slow-burning cosmic dawn, but by a cosmic firestorm, a brief but explosive era of intense, chaotic, and unexpected evolution. The discovery of Mom Z14 didn't just add another data point to our cosmic ledger. It ripped open a fault line beneath one of science's most sacred models, the timeline of galaxy formation. You see, for decades, astronomers believed that the early universe was a slow and quiet place. After the Big Bang, it took hundreds of millions of years for the first atoms to cool, for gravity to sculpt matter into clouds, and for stars to ignite. Galaxies, it was thought, would take even longer, slowly assembling over billions of years through mergers, collapses, and cosmic evolution. In this framework, early galaxies were expected to be tiny, dim, and chemically primitive, mostly made of hydrogen and helium, the universe's first elements. But Mom Z14 defies every one of those expectations. It's bright, suggesting a high rate of star formation. It's compact, yet incredibly efficient at producing stars. And it's chemically enriched with measurable nitrogen, an element that takes multiple stellar generations to produce. In short, Mom Z14 is acting like a fully developed galaxy at a time when galaxies weren't supposed to exist at all. And this wasn't an isolated fluke. Since JWST began its mission, astronomers have found dozens of similar galaxies, small, red, and extremely ancient. They've been dubbed little red dots. These objects are turning up across multiple JWST deep field surveys, suggesting that hyperactive, star-forming galaxies may have been far more common in the early universe than anyone predicted. If that's true, then the entire narrative of cosmic evolution, from first light to galaxy clusters, may be built on incomplete assumptions, and scientists are beginning to admit it. Dr. Erica Nelson of the University of Colorado put it plainly: these early galaxies are more massive, more mature, and more chemically evolved than our models allow. Something doesn't add up. Even the Lambda CDM model, the most accepted model of cosmology, which includes dark matter and dark energy, struggles to account for the speed and complexity of these early systems. So what are we missing? Is it the physics of early star formation? Is it the role of dark matter halos in assembling structure faster than we thought? Or are we staring at something much deeper? Because as strange as Mom Z14 is, what it implies about the nature of our universe is even stranger. The idea? that perhaps we're not just seeing back in time, but inside something else entirely. The strange behavior of early galaxies like MOM Z14 has pushed science to the edge of its comfort zone. But some researchers are willing to step over that edge, because maybe the universe isn't just evolving faster than we thought, maybe it isn't what we thought at all. In 2023, a study published by physicists at the University of Kansas revealed an unexpected pattern. A majority of galaxies across the observable universe appear to spin in the same direction. That might not sound like much, until you remember that a universe governed by randomness and chaos, galaxy spins should be roughly evenly distributed. But they aren't. Instead, there's a detectable bias, a preferred direction. And that points to something deeper, something embedded in the very geometry of space-time itself. Which brings us to a radical but increasingly serious idea: black hole cosmology. Also known as Schwarzschild cosmology, this theory suggests that our entire universe, everything we see, from galaxies to dark energy, might actually exist inside a black hole. It sounds like science fiction, but the logic behind it is striking. Both a black hole and the Big Bang begin the same way: a singularity, an infinitely dense point in space. Traditionally, we think of a black hole as a dead end, a place where matter collapses forever. But some theories suggest otherwise. According to the Einstein-Cartan theory, which expands on general relativity by including a property called torsion, a black hole's core might not collapse into a singularity at all. Instead, the torsion could create a repulsive force at ultra-high densities, causing the core to rebound in what's known as a big bounce. The result? A new universe, born from the ashes of a collapsing star, inside a black hole, within a larger parent universe. And that would mean the Big Bang wasn't the beginning. It was the birth of our universe inside something else, which raises a chilling possibility. Every black hole in our universe, every single one, could contain its own baby universe, branching out into a multiverse far beyond our perception. And if that's true, then what we call the universe might be just one layer of something infinitely larger. The idea of our universe existing inside a black hole sounds extreme. It is, but what if it's also logically sound? To understand how, we need to step beyond traditional physics and into the strange world of Einstein-Cartan theory. It's a little-known extension of Einstein's general relativity, one that adds something crucial: torsion. While general relativity describes how matter curves space-time, Einstein-Cartan theory considers that matter, particularly fermions, particles with spin, might also twist space-time. This twist, or torsion, is usually negligible, but in environments of extreme density, like the center of a collapsing star, it could become powerful enough to resist complete gravitational collapse. Instead of matter being crushed into an infinitely small singularity, torsion could cause it to rebound, triggering a big bounce. And if that rebound releases energy outward fast enough, you don't get a singularity. You get a new universe. From the outside, we would only see a black hole, a boundary from which no light escapes. But from the inside, there could be space, time, matter, an entire cosmos with its own stars, galaxies, and maybe even its own laws of physics. The implications are staggering. The Big Bang may not have been a one-time explosion from nothing, but rather the continuation of something larger, a generational process, a cosmic cycle, where black holes beget universes and universes give birth to new black holes. A self-replicating multiverse. And maybe, just maybe, this helps explain why the fundamental constants of our universe appear so finely tuned for life. Because only universes born inside stable black holes survive. The rest collapse into silence. But there's one more mystery. In large-scale surveys of cosmic structure, scientists have noticed something strange. A possible preferred direction in how galaxies are distributed. A cosmic anisotropy that subtly defies the assumption that the universe is the same in all directions. Could this be a fingerprint left by the spin of a parent black hole? A kind of angular momentum imprinted at birth? We don't know. But the more we study ancient galaxies, deep structure, and fundamental forces, the more it looks like the universe has a memory, not just of where it's going, but of where it came from. As tempting as it is to imagine our universe as the child of a black hole, not all scientists are ready to abandon the standard model just yet. Because while Mom Z14 and galaxies like it are undeniably strange, there's another possibility we need to consider. What if we're simply misinterpreting the data? One major concern is the accuracy of redshift measurements at extreme distances. Although JWST's instruments are extraordinarily precise, some astronomers caution that early photometric redshifts, estimates based on color and brightness, can overestimate distance. That's why spectroscopic confirmation is so important. Mom Z14 has passed that test, but some galaxies with similar properties haven't, at least not yet. So the question becomes, are we seeing ancient galaxies or just misunderstood ones? And there's also the issue of galactic rotation speeds. If we've underestimated the velocity at which our own Milky Way is spinning, it could slightly distort how we calculate distances across space, possibly creating the illusion of impossible galaxies. And then there's the role of dark matter. Dark matter may have allowed early structures to form more quickly than visible matter models predict. If galaxies like Mom Z14 formed inside massive dark matter halos, their evolution could have been accelerated, giving rise to starbursts and chemical enrichment far earlier than expected. So maybe the universe isn't breaking the rules. Maybe we just don't fully understand the rules yet. And that's the beauty and the challenge of science. The line between discovery and error is razor thin. But what's certain is this: the James Webb Space Telescope is revealing things we never imagined, and with every image, every spectrum, every strange little red dot, it's inviting us to rethink everything. Mom Z14 is just one galaxy, a tiny red speck buried deep in a patch of ancient sky. But its existence has echoed through the halls of science, forcing us to re-examine everything we thought we knew about the early universe. We expected a quiet cosmic dawn. What we found was a roaring furnace of creation. Galaxies forming faster, stars dying sooner, chemistry advancing at impossible speeds. And with every new discovery, JWST isn't just answering questions, it's asking better ones. Could galaxies like Mom Z14 be common, not rare? Could the Big Bang itself be part of a larger cycle, a bounce, not a beginning? Could we be living inside a black hole, watching our cosmic ancestors from within? The truth is, we don't know. And that's what makes this moment so powerful. Because right now, we are living in a time of discovery. A time when the universe is revealing its secrets one red dot at a time. And the deeper we look, the more the cosmos reminds us we've only just begun. There's more out there, much more, and we'll explore it. one mystery at a time. Stick around. The next question might be even stranger.